Hello students, yesterday or in my last video we discussed the two defects in solids, that is stoichiometric defects and another one is the non-stoichiometric defects. We studied the types of stoichiometric defects in ionic compounds and non-ionic compounds, and also we studied non-stoichiometric defects where there in non-stoichiometric defects there are two types. One is metal excess and another one is a metal deficiency defect. And another one, third type of the defects found in solids is impurity defects. So here, as the word itself says, it is an impurity defects. So this defects arises in the solid due to the presence of impurities. For example, during the formation of sodium chloride crystal. Sodium chloride crystal. So here, this is the arrangement what we are expecting. There is sodium chloride. So this is one crystalline compound, sodium chloride. But if some impurities are present in that sodium chloride crystal, so during formation of that sodium chloride crystal, if strontium chloride is present as an impurity. So here students, the strontium is Sr plus 2. The charge on this is Sr plus 2. That means each strontium atom will replace two sodium ions. So this is a dipositive. If strontium is present as an impurity, so this Sr plus 2, it replaces two of the sodium ions. This is the one sodium ion is replaced by Sr plus 2 and there is another one vacant is created. One vacant, let us know it is vacant. It also replaces another one sodium atom. It is because to maintain the electrical neutrality of the crystal. So that's why two of the sodium ions are replaced by one strontium. And there is one vacancy is created. One lattice point is vacant. So there is a defect, and that defect arises due to the presence of impurities. So therefore, such defects are called as impurity defects. Now students, this is all about the defects or imperfection in solids. And the next one is electrical properties of the solids. Again, we classify the solids based on its electrical properties. So solids are classified into three types. One is conductors. Second one is insulators. Third one is the semiconductors. These are the three types of the solids. Solids are they are conductors, insulators, or the semiconductors. And since here the conductors means the one which carries the current, that is we call it as conductors. Again, is solid substance, if it carries the current, okay, then we call it as conductors. Insulators are the one which does not carry the current. Right? And semiconductors, they are in between conductors and the insulators. And since here in conductors, the conductivity it ranges in the range of 10 raised to 4 to 10 raised to 7. Is the conductivity, it is in the range of the 10 raised to 4 to 10 raised to 7. Is measured in ohm per meter. Whereas the insulators it ranges from 10 raised to minus 20 to 10 raised to minus 10. And semiconductors, they are in between that. There is a 10 raised to minus 6 to 10 raised to 4. Its conductivity of the conductors is measured and it is in the range of 10 raised to 4 to 10 raised to 7. And semiconductors whose conductivity is 10 raised to minus 6 to 10 raised to 4, where insulators they are does not conduct electricity, where its conductivity is 10 raised to minus 20 to 10 raised to minus 10. Now students, let me discuss these conductors and semiconductors in terms of band theory. See, in band theory, we define two bands. One is the conduction band, another one is the valence band. Okay. So, conduction band and the valence band. So, conduction band is the valence band, and this one is the conduction band. Conduction band and valence band contains valence electrons. A substance contains valence electrons in the valence band, and in conduction band there is an empty orbitals are present. So here the valence band orbitals contains a electrons, lone pair of electrons. Okay. So here conduction band there is no electrons, there is an empty orbitals. Okay. So what happens is in conductors, this valence band and conduction band they are overlapped, because this is the conduction band and this one is the valence band. There is no gap between the valence band and the conduction band. Okay. So here this is the valence band and this was the conduction band. Both are overlapped. Okay. So it is very easy to jump an electron from valence band into a conduction band. Okay. The electrons can easily jump from valence band into conduction band and they carry the current. Okay, so that's why they conduct the electricity. Okay. And in insulators, there is a large gap is present. There is a large energy gap is present between the valence band and the conduction band. So this gap we refer as an energy gap. So, in insulators, there is a large energy gap present between the valence band and the conduction band. Now, the electrons which are present in valence band, they cannot move into a conduction band. It is very difficult for an electrons to jump from valence band into conduction because of the large energy gap. Okay, they need lots of energy to jump a electron from valence band into conduction band. Almost it is impossible, so therefore they does not conduct the electricity. Therefore we call those solid substances as insulators. And another one is the semiconductors. In semiconductors, it is in between that conduction band and the valence band. Okay. The energy gap between the conduction band and valence band in semiconductor is less. There is a small energy gap is present between the valence band and conduction band. So this is the valence band and another one is the conduction band. Okay, so here the electrons. So these are the electrons. Okay. So now the electrons can easily jump from a valence band into a conduction band. Just if we heat that substance, so electron can easily jump from valence band into a conduction band. Okay. So because there is a small gap is present between the valence band and the conduction band. So like that we can explain these types of solids based on its band theory. So let me repeat once again students here, the band theory. So band theory means there are two bands. Okay. So one of the orbit which contains valence electron that we got as a valence band, and there is another one orbitals where vacant orbitals. Okay, there is a conduction band. So if the electrons which jumps from valence band into the conduction band, then only the electricity flows. So this arrangement of this valence band and conduction band in conductors is they are overlapped, that the electrons can easily jump from valence band into conduction band. In conductors, therefore conductors can carry the current. Okay, And in insulators, there is a large energy gap between the valence band and conduction band. So here, these insulators does not carry the current because there is a large energy gap. And in semiconductors, there is a small energy gap. Okay. So if you provide certain amount of energy, so these electrons gain that energy and jumps into from valence band into conduction band, and they conduct the electricity. Now states the temperature, by increasing the temperature, the conductivity of these semiconductors increases. Because by increasing temperature, the energy of these electron increases. By increasing temperature, more number of electrons jumps from valence band to a conduction band. Whereas in conductors, this is in a reverse way. If we increase the temperature of a conductor, the conductivity of the conductors decreases. It is because here the electrons are arranged in an order. So the electrons moving in an order. So all the electrons, they are arranged in an order, and the movement of these electrons from valence band into a conduction band is also in an order because these two bands are overlapped. Okay. So if you increase the temperature of these conductors, so this arrangement is disturbed. So that we call as an agitation. There is a thermally disturbance. Okay. So this arrangement is disturbed, therefore the conductivity decreases. Okay, that effect we call as a thermal agitation. Okay, there is a disturbance in the order of these electrons by heating. So that's why the conductivity of these conductors decreases by increasing temperature. And in semiconductors, the conductivity increases by increasing temperature because here there is some gap is present between these two. Okay. So if you provide more heat energy, more number of electrons can jump from valence band into a conduction band, and the conductivity increases. So this is about the electrical properties of the solids based on the band theory. So next is, let me discuss in detail about the semiconductors again. Semiconductors, just now we defined that semiconductors are the band that does not conduct the electricity, but by increasing the temperature, they conduct the electricity. By increasing temperature, the conductivity of semiconductor increases. Now stress, these semiconductors, again they divide into two types. One is intrinsic semiconductor, another one is the extrinsic semiconductor. Intrinsic semiconductor, another one is the extrinsic semiconductor. These are the two types of the semiconductors, intrinsic and extrinsic. So intrinsic semiconductor, it is also called pure semiconductor. So extrinsic semiconductors, these are the semiconductors, impure semiconductors are, these semiconductors are prepared by doping. Okay. So they contain some dopant. Okay, let me go with that later. First, let me discuss about this one. Intrinsic semiconductors. Intrinsic semiconductors, they are pure semiconductors like silicon and germanium of group 14 elements. Silicon and germanium, they are pure semiconductors. They does not conduct the electricity. Okay. So to conduct the electricity, we need free electrons. Okay. So in pure semiconductor is a bad conductor. See friends, it is because in silicon, let me take this silicon. So silicon, it belongs to carbon family. That means it is in a tetravalent. It contains 4 valence electrons. So each silicon is bonded with another 4 silicons. Like this is the structure of a solid silicon. So here all all the electrons are shared with the neighboring silicon. So this silicon has 4 valence electrons, it is shared with the neighbors. Like that, there is no free electrons. Therefore, pure semiconductor, pure silicon is a bad conductor. So pure silicon and the germanium, they does not conduct the electricity. So those are called as intrinsic semiconductors. Right? Next friends, the another one is extrinsic semiconductors. Now, so extrinsic semiconductors. Let me go with that. Extrinsic semiconductors are prepared by doping. Okay, so where dopant are added. So dopants are present. Dopants means dopants are the impurities. By adding an impurities, so the conductivity of these semiconductors increases. Okay, so if if that silicon or germanium, it is doped with some impurities, or by addition of some impurities to that pure silicon or pure germanium, the conductivity of that silicon increases. Okay. So that type of semiconductors we call as intrinsic semiconductors. Now let me with an example. Let me take the silicon. It belongs to 14th group. Let me add some impurities from a pentavalent. So pentavalent means from group 15. Group 15 element, like our phosphorus and arsenic, etc. So are the group 15 elements. When these group 15 element is added to group 14, so group 14 element is silicon. When it is added to a silicon, so in group 15 element, the total number of valence electrons here is 5. Arsenic or phosphorus, they contain 5 valence electrons. 5 valence electrons. When we dope that arsenic to a pure silicon, that means one of this silicon is replaced by arsenic. I am replacing this one silicon by an arsenic. Okay. So arsenic, it contains 5 valence electrons. It means it shares 4 electrons with the neighboring silicon atoms. Okay. So by sharing electrons, they form the bonds here. Okay. So it shares 4 electrons with the neighboring silicon atoms and forms the bond. Along with that, there is another one electron is present in that arsenic. So here, okay, there is another one electron present on that arsenic. Okay. So that electron carries the current. Okay. So that electron, when it jumps from here to another, so it is moves in that semiconductor, so that carries the current. Okay. So here the electron, the free electron carries the current that can increase the conductivity of that semiconductors. Okay. So here electrons are carrying the current, so therefore we call such type of semiconductors as N type of semiconductors. So these are called as N type of semiconductors. N-type semiconductors. N is used as a negative, and it stands for negative because electrons are responsible for carrying the current. Okay, so electrons are negatively charged, therefore it is referred as an N-type of semiconductors. Now since the next one is the one N-type of semiconductors, and second one is the P-type of semiconductors. So to prepare a P-type of semiconductors, so here the P stands for positive. Okay. So to prepare the P-type of semiconductors, we add impurities from group 14. So group 14 elements like boron, aluminum are used as a dopant. Okay. So which are added to a pure silicon. Okay. So let me place here. So this arsenic, now I am replacing that by an aluminum. group 13 elements. Sorry, this is group 13 elements. Is boron and aluminum. So these are called trivalent. Trivalent impurities like boron and aluminum. So here the total number of valence electrons present in this aluminum and trivalent are 3. So here the 3 valence electrons. Okay. So when we add this aluminum to a pure silicon, so 3 of the electrons are shared by 3 silicon atoms. So these 3 electrons of aluminum shares with other 3 silicon and forms the bond. And 1 electron left as it is. 1 electron from this silicon left as it is. Now there is 1 electron is left, and due to this there is no bond is present between this aluminum and silicon. A hole is created here. Hole means the deficiency of the electron. There is no bond is present, so 1 electron is required to form the bond between silicon and aluminum. Okay, this is a deficiency of electron, or there is a hole is created. This is called hole. Now that hole is a deficiency of electrons. Now these electrons jump from here to here and forms the bond between these two. Okay, so here the bond is formed between these two. Okay, sorry. This electron jumps from here and forms the bond, and hole is created here. Okay. So holes are moving in one direction and electrons are moving in another direction. Like that, the conductivity of that silicon increases by the movement of this hole. Okay. So therefore, we call here holes are responsible for the conduction of electricity. Okay. So holes we call as an electron deficient spaces. So those are positively charged, therefore it is called as a P type of the semiconductors. Next concept in solid state cells is the magnetic properties of the solids. Here once again the solids are classified based on the magnetic properties. So based on magnetic properties, the solids are classified into 5 types. So the 5 types are: one is diamagnetic, second one is the paramagnetic. These two properties already we learned, diamagnetic and the paramagnetic. Diamagnetic, it repelled by the magnetic field, so the substances they are repelled by the magnetic field, and paramagnetic, so where the substances are attracted by the magnetic field. So magnetic field means, so for example, these are the magnets N and S, and if I keep the substance between these two north and south pole, if it is attracted by that magnet, so then because it is a paramagnetic, if it is repelled by the magnet, we call it a diamagnetic. So here there is this circle we call it a magnetic field. Last is the diamagnetic substance is the one. Diamagnetic substance and paramagnetic substance. So in a diamagnetic substance, the substance which contains a paired electrons. So here diamagnetic substance, the substance which contains a paired electrons, and they are weakly repelled by that magnetic field, then such substances we call as a diamagnetic. Okay. If any solid, if it contains paired electron and also it is weakly repelled by the magnetic field, then that is called as a diamagnetic substance. And paramagnetic substance, it contains unpaired electrons. Unpaired electrons, if the substance contains unpaired electrons and that substance is attracted by the magnetic field, so such substances we call as a paramagnetic. This is the common difference between diamagnetic and paramagnetic. Here students, before I proceed with the other types of the solid substances, so here let me explain you why these solids they attracted by the magnetic field. What is the role of the electrons? So in paramagnetic substance and in diamagnetic substance, we know that there is an electron. It is revolving around the nucleus. So if it is a nucleus, the electrons are revolving around this nucleus. So these are the electrons, and simultaneously the electrons revolving around its own axis. It is also revolving around its own axis. It is revolving around the nucleus, and also it is revolving around its own axis. During that rotation, there is a small amount of electricity is generated in that atom. So therefore, that is also behaves like in a small tiny magnet. Then that magnet is attracted by the magnetic field. So when it is kept in a magnetic field, it is also attracted by that magnet. So if that substance contains only one electron, so that means unpaired electron, so then it is attracted by the magnetic field and it behaves like in a paramagnetic. If there are two electrons, paired electrons are present, so where one is rotating in clockwise and another one is rotating in anti-clockwise, so the total charge developed in that is cancelled by these two electrons. Therefore, it is weakly repelled by the magnetic field. The substance which contains paired electrons, it is weakly repelled by the magnetic field. That's why it behaves like in a diamagnetic. So this is about the paramagnetic and diamagnetic. For example, diamagnetic, for example, water. So water is also a diamagnetic substance. Benzene C6H6 is a diamagnetic substance, and paramagnetic substances like iron Fe+3, they contain unpaired electrons. So the other elements like aluminium, metals, they are paramagnetic substances. They are attracted by the magnetic field. Next, students, other than these two, we classify again solids into three types. Another three. There's one is ferromagnetic, antiferromagnetic, and ferrimagnetic. Ferromagnetic substance, antiferromagnetic substances, and ferrimagnetic substance. And since here, ferromagnetic substance, they also contain unpaired electrons. Antiferromagnetic substance also contains unpaired electrons. Ferrimagnetic substance also contains unpaired electrons. But ferromagnetic substances are the one which shows a enhanced magnetic moment. Whereas antiferromagnetic substance, they also contains unpaired electrons, but they behaves like in a diamagnetic. Whereas the ferrimagnetic substances, even though they contain unpaired electrons, they shows a suppressed magnetic moment. Its magnetic moment is less than the paramagnetic substances. Okay, let me explain you why there is a difference. See, first let me go with the ferromagnetic substances. Just now, let me take one solid substance. Say it contains large number of atoms. These all are the atoms. So all the atoms, they contain some unpaired electrons. Let me show you the unpaired electrons. These all are unpaired electrons. So this is a substance which contains unpaired electron, and here just look at this. There are few unpaired electrons which are oriented in one direction. For example, these are the electrons, they are oriented in one direction, and these electrons, they are oriented in another direction, and here these are another group of atoms which are oriented in one direction, and these are another group. Okay. The group of atoms which are oriented in one direction, so those are called domains. We call this as a domain. So this is the one domain, this is the one domain, this is the one domain, another one domain. So I am making here only the 4 domains. So group of atoms in which the paired electrons, so they start behaving like in a small tiny magnets. So these are oriented in one direction. So those are the domains. Okay, so let me show that domain by a remark like this. This is the one domain, this is the another one domain. Okay, this is the another one which is oriented here, and this is the another one. Okay. So these all are the domains. When this magnetic substance is kept in the field of magnet, all these domains they start orienting in one direction. Okay. That is, if they start oriented in one direction, this is the 1, 2, 3, 4. If all these domains are oriented in one direction, then that substance we call it a ferromagnetic substance. Okay. So ferromagnetic substance in which all the domains they are oriented in one direction. That's why it shows a enhanced magnetic moment. Its magnetic moment is more than a paramagnetic substance. Okay. So ferromagnetic substances are one. Even you can remove that substance from the magnetic field, then also they behaves like in a magnet for a long time. So even after removing that substance from the magnetic field, then also it starts behaving like in a magnet, because all these domains are oriented in one direction, where each domain contains a group of atoms, where each atom behaves like in a small tiny magnet. So here all these domains are oriented in one direction, so therefore it also behaves like in a permanent magnet. Right? So for this example is iron, Fe, iron, cobalt, nickel. Okay. So these are the ferromagnetic substances. And since the second one is the anti-ferromagnetic substance. Anti-ferromagnetic substance, what happens is the equal number of domains they are oriented in opposite direction. For example, an atom it contains 4 domains, this one, 4 domains, where the 2 domains are oriented in one direction and another 2 domains they are oriented in another opposite direction. Let me show you that. So this is the orientation of the domains. So here the 2 domains are in upward direction and 2 domains are in downward direction. That means the equal number of domains they are oriented in opposite direction. Therefore, the total net magnetic moment becomes 0. Okay. So that's why this antiferromagnetic substance it behaves like a diamagnetic. Okay. So even though it contains unpaired electron, then also it behaves like a diamagnetic because of the orientation of these domains. Let me give you examples. Oxides of manganese is an antiferromagnetic substance. Even though that contains unpaired electrons, it behaves like a diamagnetic. It is weakly repelled by the magnetic field. And since the next another one type is the ferrimagnetic substance. In ferrimagnetic substance, it shows a suppressed magnetic moment. Okay, suppressed magnetic moment means its magnetic moment is less than a paramagnetic substance. It is because more number of domains are oriented in one direction and few are in opposite direction. For example, this atom which contains 4 domains, where the 3 domains are oriented in one and another one. So say there are 5 domains are present. So there are 2 domains are oriented in one direction, 3 are in one direction. Okay. So that's why it shows a suppressed magnetic moment. Its magnetic moment is less than a paramagnetic substance. Okay. So this is a ferrimagnetic substance. So examples, there is a magnetite Fe3O4. Or ferrites of zinc and magnesium. So ferrites like Fe2O4, farads of zinc or magnesium. Okay. Those are the ferromagnetic substances. So this is about the magnetic properties of the solids. Okay, let me once again recall. There are four types: diamagnetic, paramagnetic, next ferromagnetic, antiferromagnetic, and ferrimagnetic. Okay, the substance which contains unpaired electrons, it is so that substance is attracted by the magnetic field. The substance which contains paired electrons, it is repelled by the magnetic field. So paired electrons are present in diamagnetic substance, unpaired electrons are present in all these four types. Okay. So paramagnetic substance contains unpaired electrons, it is attracted by the magnetic field. Ferromagnetic substance also contains unpaired electrons, so more number of unpaired electrons are present, and a group of atoms that we call as the domains. All the domains are oriented in one direction. It shows enhanced magnetic moment. Where next one, antiferromagnetic substance, where equal number of domains they are oriented in opposite direction. Therefore, they cancel with each other, and those substances behaves like in a diamagnetic. And lastly, ferrimagnetic substance, where more number of domains are oriented in one and few are in opposite direction. Therefore, they show suppressed magnetic moment, and its magnetic moment is less than the paramagnetic substance. The example, the ferrites and Fe3O4, these are the examples for ferrimagnetic substances. Okay, so it's about. So since this is the last concept in magnetic properties, let me recall what we have studied in our solid state till now. So we started with the classification of solids based on its nature, that is we studied about the differences between crystalline and amorphous. Then the same classification is done based on the binding force present between the constituent particles. So we classify that as ionic solids, covalent solids, metallic solids, and molecular solids. Then we define crystal lattice and space lattice. Then we studied about the unit cells and unit cell parameters. Based on unit cell parameters, that we define based on unit cell parameters, we define there are 7 crystal systems. So 7 crystal systems in which one of the crystal system is selected, that is cubic crystal system, which contains 3 types of unit cells. There is simple cubic, body centered, and face centered. So in these 3 unit cells, we calculated the percentage of the space occupied by the particles. There is packing efficiency. Okay. So packing efficiency is very important. So in exam they asked for 3 mass. So to calculate the packing efficiency in simple cubic or body centered or face centered. Then after that we studied about the closed packed structures in 2-dimensional, 3-dimensional manner. Okay. Then the next one is we saw some numericals based on unit cell dimensions. That is we calculated the density, okay, by using formula D equal to Z into M divided by N into A cube. And also we saw some numericals to calculate the formula of a compound. Okay. Just by knowing the position of an atoms in a unit cell, we calculated the formula of the compound. And also we saw some numericals based on the edge length and just by showing the relation between the edge length and the radius of sphere. After this, the next we studied about some magnetic and electrical properties of the solids. Just today we done that magnetic and electrical properties. So this is all about the solid state. Solid state is the first unit. Next, let's practice few questions given in the NCERT textbook in exercise. I can solve the numericals also.